So today we'll be solving a series circuit problem with two resistors. I'm assuming you already know Ohm's law and concepts of a series circuit, but we'll review them here as well. We'll be calculating all the components of a circuit, specifically the voltage, current, and resistance across each resistor and for the whole circuit. Even though you're solving for everything, I'm going to walk you through a simplified version of solving this. So let's get started. So let's first start out by drawing a circuit. Let's give it 12 volts. Add a couple resistors. It doesn't matter where you put the resistors because if it is a series circuit, then the resistors should all follow one path. Let's call the first resistor R1 and give it 10 ohms. Second resistor should be R2, and let's give it 20 ohms. It also helps to make a table. So let's make a table. Added voltage, V for volts. Let's add current with units of amps. And then let's also add resistance with units of ohms. You'll be calculating these values for three parts. First at resistor 1, and then at resistor 2, and also for the whole circuit, which we'll just call TC. Okay, so now you can fill out the table. What do you know? We basically know the resistance. So we know resistor 1 is 10 ohms, resistor 2 is 20 ohms. How do you calculate the total resistance in a circuit? You basically add up the resistors. So you have 10 plus 20, which is equal to a total of 30 ohms. The other information that was given was that the total voltage drop across the whole circuit was 12 volts. So we have that. If you notice here, you have 12 volts and you also have 30 ohms that you know for the whole circuit, which means that you can use Ohm's law to calculate the current. So we can say V is equal to IR, and then let's add T's to say that's for the total circuit. So then 12 volts was given. We don't know the total current yet, but we know that the total resistance is 30. Then you divide each side by 30. 12 divided by 30 is actually 0.4. So now we know that the current is 0.4 amps. And now we can fill out the table. So let's look at this table really closely. So if you notice, you have two variables unknown for resistor 1 and for resistor 2. This is not very helpful because then you can't really use Ohm's law yet, but you know that for a series, the current should always be the same throughout the whole circuit. So the current at R2 should be 0.4, and the current at R1 should also be 0.4. Now, the only thing that you have to calculate is the voltage drop across each resistor. So let's go ahead and start with resistor 1. So let's say that this is resistor 1. You can still use Ohm's law, which is just V equals IR, but let's calculate it specifically for resistor 1. So V1 is just equal to, again, the current never changes across a series circuit, so it's always going to be 0.4 for this circuit, and then the resistance is 10 ohms. So the voltage is equal to 4 volts. And let's fill out the table. So that should be should be 4. And then let's do the same for resistor 2. So at resistor 2, we have V2 is equal to I2 times R2. Voltage is equal to, again, 0.4, which never changed. The resistance here was 20 ohms. So then V2 is just equal to 8 volts. And then you can fill out the table. And there you have it. You are done with the whole circuit. I hope you found this helpful. And please check out the other videos. Thanks.